So, hello and welcome back. So, we are in the third video for the week 11 lecture, which is on air pollution. So, we will continue our discussion. We were talking about, if you remember, we are talking about global warming, climate change and those kind of issues. We just started talking about it. So, we will continue that discussion in this video and then we will go to other topics in subsequent videos. So, as this was the last slide that we were looking at, this picture was not there in the previous video. I just added this picture this morning. So, so this is the report that we are referring to. So, this is the global warming of 1.5 degrees centigrade. It was an IPCC report on the impacts of global warming. So, those of you who are kind of interested in learning more about this, you can and you should look at this report from IPCC. Which is global warming. What is the impact that we will have based on if we have an increase in temperature of 1.5 degrees centigrade. So, when we say 1.5 degrees centigrade, that is an average increase in temperature of the planet, and that leads to a lot of impacts that we talked about in the previous video as well. So, depending on change in climate, there is change in biodiversity, the stresses on biodiversity, melting of ice, impact on polar bear, and when you have more like if when the temperature goes up in colder climate, we have now more season for growing, like more demand for water, and there are so all those things comes in picture. So, those of you who are really interested in this concept, you should look at this. In fact, all of us should look at least have look at this particular report, because the impact does impact all of us. So, we will be affected by the impact. So, this is an IPCC special report on the impacts of global warming of 1.5 degrees centigrade above the pre-industrial level and related global greenhouse gas emissions pathways in the context of strengthening the global response to the threat of climate change, sustainable development and effects to eradicate poverty. Because as you know, in most of these cases, it is the poor people, it is the poor population that gets mostly affected. The like middle class, higher middle class and the rich people, they have avenues to find alternatives, but many times this poor population, they are the most vulnerable population and they get a lot of impact. So, it is the most important report ever published in 30-year history of IPCC, and air splitting wake up call to the world. Recently, you may had we had a UN session where the climate change was one of the topic, and as if you have followed it, the little girl from the young girl from Sweden, she was there. I am just forgetting at Greta, if I remember correctly, and I am kind of forgetting her name, excuse me for that. So, but you must have seen it if you have followed the UN report, UN meeting in which our Prime Minister was also there, and he gave a speech on India's commitment towards climate change and global warming and other environmental issues. So, we have to wake up, it is a wake up call now. We have to start worrying about we have to start doing action. Worrying period is over. This is the action period, and it was really nice to hear the same kind of language from the Honorable Prime Minister as well. But at the same time, it's not we need to see changes in the ground, and that's what will bring the change. See, there are people who deny climate change. Even the present US President is not that much, he does not support he does not believe the science, basically, based on, we can say that based on his speeches, rhetoric, or whatever you want to call that. So, say even if it's all nothing to do with man-made activities, it is all anthropogenic and it is all natural, whatever is happening. Even if we cut down this CO2 emissions, that's only, and get off from fossil fuel, we are going to get a lot of benefits. So, even if the climate change is not real, just assume for a minute, as many of the naysayers or the negative publicity, although there are enough science to support that yes, climate change is happening, but just in case, even if you are, if one of us is on the other side of the fence, even for those, say if we do all these measures, that is only going to help us. if you are reducing the CO2, if you are getting away from fossil fuel, that is only going to make world a better place. So, it is not that we are going to lose something, but if you do not act, we are going to lose big way. So, the call has to be made accordingly. So, the cumulative emission of CO2 and future non-CO2 radiative forcing determine the probability of limiting warming to 1.5 degree centigrade. It's as right now it says that 1.5 degree centigrade is technically possible within the laws of physics. According to the report, it is possible, but this would entail global emission of carbon dioxide decline by about 45% from 2010 levels by 23 and to 0 by 2050. At the current rate of emissions, the world will reach 1.5 degree centigrade warming by between 2030 and 2052, as in on track for more than 3 to 4 degree centigrade warming by 2100. So, those of you who are very, very young, who will be in your maybe late 70s or late 80s, today is 2019. So, if we are talking about 2100, so the kids who are burning now, kids who are born, getting born now, who are getting birth now, they will be 2019. So, they will be like 81 years of age. So, they can at 2100. So, if it becomes 3 degrees, 4 degrees by 2100. So, we will start seeing the impact by 2050 onwards, 2050s, 2060s, 2070s. So, people like me probably may not be around, but or maybe in a very, very late stage of life. But young people like many of you who are taking this course, and even people younger than you, and think about your children and grandchildren who will come in that particular era, we have to do something for them, isn't it? We cannot just leave the world in a very devastated place for our grandchildren and children. So, we have to make it a better place. That is what our parents tried to do it, although they may have made certain environmental mistakes, but it was probably not. You see, if you look at 40-50 years before, technology was not there, so that we can make those choices. We could have made a different choice, but for the last 2-3 decades, technology is there, but still we are making those old wrong choices. So, we have to move from that. Yes, anything, whenever there is a change, there will be a resistance to change, but now the science is telling us that we have to, there is no other option. That is what we have to go away from this fossil fuel, otherwise the future looks very bleak, and we will have much more problem, and those problems we may not have technical solution handy. So, that is why it's time of action is now, and it's for all of us. So, it's so if you look at the global warming related to 1850, so this graph, if you have a quick look at this graph, the cumulative emission of CO2 and future non-CO2 radiative forcing on the probability of limiting warming to 1.5 degree centigrade. So, here you are looking at the temperature on the y axis. So, that is our temperature, and then here is the years. So, is a time scale. So, 1.5 on which you see this line is at 1.5 degrees. So, that is our 1.5 degrees for that particular line, and so here based on the model you look at the different options. So, estimating anthropogenic warming to date and likely range. So, this is the range has been plotted, and this likely range of model response to stylized pathways, global CO2 emissions reach net 0 in 2050 2055. Faster CO2 reductions in blue and in B and C. So, B results in higher probability of limiting warming. No reduction in net CO2, if that is the stream that you see those purple. So, that is purple is the no reduction. So, we can even go beyond 2 degrees or 3 degrees centigrade, and that where the things does not look very good. So, the focus should be right now to how to make that 1.5 degree centigrade, at least keep it below or maximum to limiting warmings to 1.5 degree centigrade. So, this report by the world leading climate scientists as a wake up call, it confirms that climate change is running faster than we are, and we are running out of time. That was the present UN Secretary General has mentioned in one of his remarks. The report highlights a number of impact which could be limited by lower temperature increases like sea level rise. Sea level will continue to rise well beyond 2100, while it is projected to be 26 to 77 centimeter higher than 86 to 2005 baseline under a 1.5 degree centigrade temperature increase. So, we will have a 26 to 77 centimeter high. In this would mean that 10 million fewer people would be exposed to related impacts to saltwater intrusion, flooding and all that if we can control it. Exceeding 1.5, instability in Greenland, Antarctic ice sheets, which could result in multi-meter rise in sea levels over 1,000 of years. So, that is those impacts we are looking at. Then we have the ocean health, which impact on the ocean health. Global warming would slow increase in ocean acidity, whereas more than 99% will be lost within 2 degrees centigrade. Sea ice, Arctic will be free of ice. Biodiversity impact, we talked about some of these in the previous like a video as well. So, biodiversity impact will happen if 8% of plant, 4% of vertebrates, as opposed to if you have more than 1.5. So, we have 18% of insects, 16% of plants and 8% of vertebrates. Extreme events, which is again you will see extreme events, increased number of days with temperature up to 3 degrees centigrade higher. So, that means increased frequency of intensity, more amount of heavy precipitation. As you know, like this year again the rainfall pattern was very weird. So, we did not had rain when we are supposed to have rain, most of many districts in Bihar, Jharkhand, West on Bengal also we saw less rain, but Jharkhand and Bihar in many districts, there were other districts too. I am just talking about from the eastern region based on personal experiences and based on talking to people around this area, where since we have a lot of projects and other things working in, we do a lot of field work in this area. So, what we found is the rain was delayed by almost 2 months, and it has been raining very heavily very recently, like usually towards the end of September. You do not see the kind of rain which happened in this particular season, and since the rain came so late, the paddy could not be like sowed in many of the district across Jharkhand, Bihar. Now there is a flooding situation. So, right before this Durga Puja holidays, we have this flooding situation in many parts of Bengal, parts of Bihar and Jharkhand. So, it's a delayed event and it's an extreme event, less rainfall in the beginning and a long tail and a heavy tail, like a lot of rain towards the end. And so, rainfall pattern, because of the change of the rainfall pattern, the cultivation could not happen, and now with this rain, whatever the cultivation could be there, see we need rain for agriculture, but we also need timely rain. It is not if it becomes untimely rain, then it's bad for the crop. So, that may kind of lead to those kind of problem as well. So, there are also impact on human welfare, climate related risks to health, livelihoods, food security, water supply, human security, economic growth. They will increase by global warming of 1.5 degree centigrade, increase further to 2 degree. Limiting warming to 1.5 would result in 420 million fewer people being exposed to severe heat waves. So, depending on future socioeconomic condition, limiting global warming to 1.5 compared to 2 degrees centigrade might reduce the proportion of the world population exposed to a climate change induced increase in water scarcity by about 50%. So, this was warming projected by, so here current policy projections, this is the global greenhouse emissions that you are looking at. So, here you have as a year different years. So, we are near to 2020. So, we are somewhere at this point. So, warming projected by 2100. So, that is where we are looking at. So, if we pledges, if you look at the current pledges, and so this is the historical emissions, what we have the dotted dark line. The blue sets is your current policy projections. Light green is 2 degrees centigrade consistent median and range, 1.5 and below 1.5 is your consistent median and range. Pledges is it will be 2.5 below 2 degrees centigrade, will bring us below 2 degrees centigrade, and then for reference we have that baseline. So, based on this particular different scenarios, what you look at is greater than equal to 50% chance of staying below 1.5 degrees centigrade in 2100, median and 10th to 19th percentile range, pathway range excludes delayed action and blah. So, if we do all our pledges that we have as different countries, different nations, like all the population from different countries, if we look at the pledges that has been made, that will keep us below the below 1 point, below 2 actually about 2.5 to let us see. So, baseline 4.1, current policy projection. Based on the current policy, if we do not do anything, we may have increase in temperature rise by 2100 to 3 to 4 degrees centigrade. But if we meet all our pledges, we are looking at 2.5 to 2.8, which is not also very good scenario. If we do some more, and then we will be below 2 degrees and then or below 1.5 degrees. So, it requires a lot of effort. So, how the level of global warming is affecting impact, what are the reasons of concern for select natural, managed and human system? There are 5 reasons, there are 5 reasons for concern, which is RFCs listed the impact and risk of different levels of global warming. So, purple color here or red, you see the reddish kind of color indicates very high risk of severe impacts. Red indicates severe and widespread impact. Yellow is the impact risk are detectable and attribute to climate change with at least medium confidence. White indicates no impacts are detectable and attributed to climate change. So, here unique and threatened systems, extreme weather events, distribution of impacts, global aggregate impacts, large scale singular impact, level of additional impact to risk due to climate change. So, those are different categories in which we are looking at for different scenarios, and we see that there is if you look at the global mean surface temperature change relative to pre-industrial level, which if you go to around when we go to the 3 lines that has been shown here, the 2 degrees centigrade, which is the top line, then you have 1.5 degrees centigrade, and then we have 1 and below, which is the range from 2006 to 2015, they are like a baseline. So, based on that, if we can keep us below 1.5, we are still will have certain impacts, risk, or which will be there, but we have to come up with mitigation for that. But once things go beyond 2, most of the impacts are in very high risk. So, that is the reason why there is a lot of push for keeping the global warming temperature, like increase in temperature, to be less than 1.5. So, in terms of impacts, what impacts we are looking at, again the same color here at the bottom one. If you can look at this bottom graph here, this graph over here. So, if you look at the warm water corals, mangrove is small scale, low latitude fisheries, Arctic, terrestrial ecosystem, coastal flooding, fluvial flooding, crop yield, tourism, heat related morbidity and mortality. So, those are the different parameters, and as you can see, again you have confidence level. L is for, you see a lot of numbers here. L is for low, M is for medium, H is for high, and VH is for very high. You see all those numbers over here, and this dark purple, or I think I'll probably call it, yeah, it does look like purple. If you're not a if you are a color blind, then it's a problem, but otherwise that these numbers, these do look like purple. So, if we have a purple, that means very high risk. So, very high risk for warm water corals, very high risk for in the Arctic region, and then we have red mostly. And so, when we have red or yellow, it's a severe and widespread impact, indicates impact and risk. So, as you can see, for most of these parameters, except for the example mangroves, we are saying no red, only yellow and white, but for most of it there is a set of yellow, which in terms of impact that may potentially happen because of the climate change. So, most in terms of climate action tracker, what can be done in terms of to do it as steps for 1.5 degree centigrade world. So, these are the things that as a world we need to do it. So, we have to sustain renewable growth. So, renewable energy has to be, we have to have more and more renewable energy. So, that is very, very important. So, we need to get this renewable energy in our energy profile. We need to have this renewable energy coming in. No new coal power plants. That's one we have to get rid of get out of coal and do other renewables. Last fossil fuel cars sold before 2035. So if after 2035 we are still using fossil fuel car, then it will be a problem. This is again based on all the models. Develop 1.5 degree centigrade vision for aviation and shipping. So aviation sector again is a big carbon CO2 emission area. New industrial installation with a low carbon after 2020, zero deforestation, best practices in agricultural, zero building, new buildings should have zero emissions from 2020, renovate 30 to 5 years of building per year. So we have to renovate the old buildings, make it more energy efficient. Many of the older buildings are not at all energy efficient, and now with this air conditioning and all that we are used to, that we are using, if you don't renovate and don't keep it up with the newer technology with, and so it keeps on becoming a energy like a, they eat up a lot of energy, and then that has a environmental impact as well. So annual CO2 emissions in 2016, this was the CO2 emission measured in tons per year. So as you can see, the countries which are in the darker color are emitting more. So China, and for the US and Canada, US and China, they are the kind of the darker color. Then the sets gets a little bit lighter. So India is in the second category. So we are actually, I think, in the category of 3 billion tons to 5 billion tons, in that range, and our USA and China, they are in the 10 billion, 5 billion, 7.5 to 10 billion tons, that particular range, and others are if you look at the others, they are lighter, so they are producing less, they are emitting less CO2 per year. But one thing you have to understand, that China has a huge population, US has much lesser population compared to China, but in terms of CO2 emissions, in fact they are on the same platform. So that means per capita CO2 emissions in China is much lower than in US. So it's US, it's much higher as compared to rest of the world, including for China. So if you look at the annual CO2 emissions for the world region, again this is 2015 data. So India is right there. So if you look at the biggest contributors, China, US, Americas, other Americas country, Europe is there, and India is kind of similar to Europe, slightly maybe lower than Europe, or maybe slightly higher. That's the present status. But if you look at historically, an interesting thing to look at historically for example, for this in Europe, where you can EU 28 or even the other European countries, there was a huge increase, but then there was a decrease. So the US has adopted a lot of green energies, so that's why you see a kind of dip in there. In US also we start seeing some dip in terms of annual CO2 emissions that is coming out. So annual share of global CO2 emissions, if you look at for the share wise, again our China, it's in a very high end, and then followed by US, then India, and several other countries accordingly there. So again you can see from the bottom, like anything from left to right, lighter sets, and then we get darker and darker. So these are based on data based on Global Carbon Project in 2017. So this is carbon dioxide emissions by sector. So transport sector is a major, electricity and heat production is another one, manufacturing, residential building, commercial and public services, and the others. So the big, when we say the big cat in the room, so if you look at the big four is electricity and heat production, transport, manufacturing, industries and construction, residential building, and commercial and public services. So those are the four major industrial area where if we can focus on reduction of CO2 emissions, we can actually do a lot of work there. Electricity, of course, looking at the alternative energy is always like non-fossil fuel energy is going to help. Transport has to become more efficient. Public transport needs to be promoted but unfortunately that doesn't get done is still a lot of public transport is not that common in many parts of the world. So, if you look at the carbon emission intensity versus GDP per capita, now until then we have been looking at total for countries. So, and that's many times that does not give you a very clear picture, because when you look at per capita, then it kind of puts everybody kind of on the same platform. So, if you look at in the bottom is GDP per capita, and that is the x axis. X axis is GDP per capita, y axis is emission intensity per capita. I think carbon emission intensity is the ratio between emission of CO2 in kg out to the output of economy in international dollars. So, that is the so here the emissions intensity is given here, GDP per capita is over here. So, if you can plot it, as you can see, you will see that China is again pretty high in terms of if you look at the GDP per capita. Is somewhere here. So, China is more than 10,000, and then we have 0.6 kg of CO2, which is in emissions in kg in CO2 to the output of economy in international dollars. So, India's our per capita is much lower compared to China, nearly half of that, so slightly more than half. So, our emissions are also kind of in the middle. Nearly half actually from what is in from the China point of view, but as if you can look at the other countries. So, one trend, there is not really a trend we can say, there is not very clear trend, but one thing we can, for many countries we are seeing that as their GDP is more emission intensity is also there. So, like Trinidad and Tobago pretty high, and then they have decent per capita income as well. Aruba, Bahrain, Saudi Arabia, Qatar, US, pretty high GDP per capita, but emissions is kind of slightly lower than in India if you look at the per capita. So, that means more energy efficiency is carbon emission intensity is the ratio of emissions of CO2 to the output of economy. So, that is we are getting in terms of they are getting better in terms of energy efficiency and all that. CO2 emissions by source, what are the different sources? From solid fuel, from liquid fuel, from gas, for cement, from flaring. So, the flaring is the landfill part, but other than that it is all CO2 from cement is there a little bit, but then gas, liquid fuel and solid fuel. So, that is major. So, it is a fuel consumption which is the major. So, we have to, if we can get rid of if we can go for renewables, and that always is going to be better as long as the renewables are good. So, renewables, one of the renewables is the solar panels. So, solar panel uses a lot of heavy metals, a lot of rare earth metals are used there. So, and then when the solar panels will be taken off because of it cannot be used any further. So, it has been replaced by a new one. So, that will become a solar panel waste. So, right now we are looking at that actually to see with how much kind of a life cycle approach to on the solar panel. So, atmospheric CO2 concentration, so we have global average atmospheric concentration of CO2 measured in parts per million. So, as you can see, we are like in up to 2016, I've seen the last some 50 to 100 years, there is a huge increase. Earlier it was kind of constant around 280 ppm, but then there is a sharp increase to 400 ppm over last you can say 150 to 200 years. CO2 emissions in important goods is a share of domestic emissions. So, since things are emitted, so it is a share of carbon dioxide emissions embedded in trade, measured as emissions exported or imported as a percentage of domestic production emissions. Positive values means red represents net import of CO2, that is 20, for example 20% would mean a country imported emissions equivalent to CO2, 20% of its domestic emissions. Negative value means that it is a net exporter of CO2. So, when we are looking at for example, in the case of like in the Indian case, we are actually in the negative. So, we are exporting CO2. So, we are like we are producing goods and other stuff, and as part of trade we are actually net exporter of CO2 emissions rather than importer. And so, that is just a way of looking at things. CO2 per capita, again US, Canada, those are comes out to Australia, some of the European countries, some Middle Eastern country, they come out to be much higher. And in Indian context, again, because of per capita, it is still pretty low. CO2 emissions per capita versus GDP per capita. So again, you can see some countries like Qatar, Kuwait, here you see a much better like a trend that the more the GDP per capita, more per capita CO2 emissions. So which you can illustrate using this. CO2 emissions per capita versus share of people living in extreme poverty. Again, those countries where people are in extreme poverty less, we see more per capita CO2 emissions. As we go to poorer and poorer country, actually we see less per capita CO2 emissions. So a different world region, European Union, still European Union, US, Americas, others, India is there, China. So China is picking up, United States is still pretty high, Asia and Pacific, then European Union and other European countries are there too. So cumulative CO2 emissions from different countries since say 1751. So again, India is kind of in the middle in terms of emissions coming out. Energy use per capita versus share of population. So again, we can look at per capita energy use versus population, extreme poverty. Poor countries, you will see less per capita, richer countries, you will see more, and that's kind of what it shows up. Global CO2 atmospheric concentration, it's kind of picking up, global mean annual concentration of CO2. So these are some of the global warming potential of greenhouse as a function in 100 years scale. So SF, PFCs, nitrous oxide, methane is around 28, carbon dioxide is 1. So it's in terms of greenhouse impact. Greenhouse gas emissions by gas, CO2 by gas world. So it's by measured in tons CO2 equivalent. So we can look at how much from carbon dioxide, methane, nitrous oxide, HFCs and all that. Methane emissions by sector, energy sector, agricultural sector, those are the major ones in terms of methane coming out. Nitrous oxide emissions, again agriculture is the number one. Share of global cumulative CO2 emissions, you can see the US, then the European Union, China is picking up, India is also picking up, UK is going down. So in terms of the share, US and UK is going down, in the European Union share is also going down, and India and China shares are increasing. This is the temperature anomaly for over 1961, 1990. As you can see, there is a gradual increase in temperature. Global greenhouse emissions, we already kind of looked at this. This is just a repeat of that. So let's. So this will be the last slide, and then we'll stop. So here, if we can look at in terms of during unstable condition. So let's stop here. We'll start this in the next video. So this is so far in this particular video, we have kind of focused on looking at the global climate change, the impacts on different. Look at the global scenario in terms of which countries are producing more more CO2 equivalent compared to other countries and different sectors and all that. So those are important to know, because to have a target of 1.5 degree centigrade maximum increase in like a mean temperature, we have to look at what are the different industrial area with the different countries who are kind of hotspots. So this is when you start working as a part of sustainable development goals, SDGs of United Nations. All companies, all organizations are kind of part of that. So you will have to meet certain goals, and then you can look at how your goals will actually help in terms of climate change and global warming and all those kind of stuff as well. So again, thank you. So we completed the third video of week 11. So we have we'll move to the fourth in the next kind of module. So thanks. Keep the discussion board active, and I look forward to hearing from you on the discussion forum on how the course is going so far. Thank you.